Good evening, students. My name is Samuel Chukwuemeka. Welcome to this video segment. In this video segment, we shall talk about combinations. Combinations and permutations. They are part of combinatorics, which I explained earlier. Please, before you view this video segment, make sure that you have viewed the video on combinatorics, video on counting, then the video on permutation, okay, before you now view the video on combinations. Alright, because we shall use our knowledge from permutations to now work on this. Okay, in permutations we define it as the ordered arrangement of a set of elements. We say that the permutation of a set of elements is the ordered arrangement of the set of elements. Now, what of combination? In combination of a set of elements is just the selection of the set of elements without paying attention to the order of selection. We don't care about the order. And that is the difference between permutation and combination. So we can say that combination is defined as the selection of a set of elements without regard to the order. Okay, to the order of selection. We don't care about the order of selection. So when we care about the order, we mean permutation, and we don't care about the order, we mean combination. I hope to do more videos on this to explain this more. Alright, let's go ahead to the questions. List the combinations of A, B, and C. First of all, before we do this, let's list the permutation of A, B, C first. Then we can list the combination. Okay, so list the combinations of A, B, C. In this case, before we list the combinations of A, B, C, let us first of all list the permutations of A, B, C. Okay, we have permutations of A, B, C. Then we have combinations of A, B, C. Okay, in permutations of ABC, like we did in the other video, we have ABC, ACB, BAC, BCA, CAB, CBA. That is 6. Now, but in the combinations of ABC, it's just going to be ABC. Because in combination, provided that the 3 of them is there, that is what matters. You know, ABC. ABC is all these. And that's it. So the combinations of ABC, just 1. This is 6 and this is 1. You see, we don't care about the order of arrangement in combination. We don't. That's the thing about it. Okay? And later we're going to derive a formula on this. You know, we're going to kind of derive a formula on this. Now, let's go to the next one, number 3. If K is equal to ABCD, right? If K is equal to ABCD, list the 2 combinations of K and then the 3 combinations of K. Alright, so we have ABCD. First of all, let's list the 2 combinations of K. Let's list it first, right? So we have AB, BA. AB and BA, it counts as 1, AB. Then we have AC and CA. It counts as 1, AC. This is ABC, yeah, ABC. Right? Then we have AD and DA. Right? It counts as 1 AD. You know, these two combinations of that, but this is two combinations of this. permutations of this, and then two combinations of this. So I guess we're done with the A. So let's go to the B. Here we have BC and CB. It counts as one, BC. Right? Then we have a BD and DB. Counts as one, BD. Right? Then we have a CD. CD and DC counts as one, CD. So let's kind of, you know, if we have 4 palm 2, because this is like taking 4 palm 2, which gives us 4 times 3, 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then here it's like 4 come 2. You know what I'm going at now? I'm trying to derive a formula for N com R, just like I did in M palm R. Okay, and this short form, you know, we can say the short form com. Short form is com. Informally, just like I wrote palm 3 from 4, com 3 from 4, combination. Okay, 4 com 2 will give you 4 times 3 over 2, which is 2 times 3, 6. 1, 2, 3, 4, 5, 6. And, yeah, so you see how combination works, you know, because AB and BA is just AB. Simple, it's that AB. So that is the way it works. Now, and it's not going to be like we have 6 here, we have 12 here, therefore you divide 2. I don't want to teach you that, you know, I don't want to teach you that, no. Just list it first, then we shall come to the actual formula that you will use. Okay, that's, we just did A. Now let's do 3B. 3 combinations of K, 3 combinations. Okay, so let's list the 3 combinations of this, and as we are listing it, we list the, let's first of all list the 3 permutations of this, and as we are listing it, we list the 3 combinations as well. Right? So 3, this is like palm 3 from 4, 4 palm 3. A, B, C, right? Or it could be A, C, B, right? It could be A, B, C, or it could be A, C, B. Okay, now this gives us just A, B, C. That's what it gives. And if we do this also, B, A, C, B, C, A, right? And then C, A, B, C, B, A. So this stuff, this 6 is just ABC, period. It's just ABC. Then we do A, B, D, A, D, B, right? And here we could have a B, A, D, B, D, A, right? And here we can have a D, A, B, D, B, A, right? And all these 6 is just ABD. ABD. That is what it is. Because it is included, A, B, and D is included in all of them. Right? Then we could have a C, D, or A, D, C. Right? We don't have a B here. So we could also have here a C, A. You know what? I can kind of list my D here. So D, A, B here, D, B, A. Okay? So back here, we have a C, A, D, or C, D, A. And here we could have a D, A, C, or D, C, A. Now, you know, I kind of want you to follow the order I'm listing this. You know, and you can try it, you know. So all these things gives us ACD, period. It gives us ACD. It gives us only ACD. Okay. Then we, of course, this we're expecting 24 from this because 4 palm 3 is 24, right? So yeah, it's 24. So now 4 palm 3 should be 4. So now let's finish listing this. So the next one here is DCD. We've not listed BCD or BDC. And in C, we have CBD or CDB. Then we have a DBC or DCB. So all this stuff, all of it gives us BCD, period. So if you look, you see that, you know, each of these are separate, you know, separate, distinct from all this, you know. Yeah, if you check all this, you see each 6 is just 1 because it has a lot. All right, so that is a 3B. We just answered the 3B. Okay. All right, number 4. Palm and comb. That's what I used to call it in Nigeria when I was teaching it. Palm and comb. Okay. Number 4, in how many ways can we select a committee of 3 from a group of 10 people? Now, before I go into this, let's look at what we just did. Now, when we found the 2 combinations of K from 4 elements, that is like 4 come 2. Okay? The combination of 4 elements taking 2 at a time, okay? And of course, like we said in the other video, n come r, you can write it like this: superscript n combination subscript r, or some textbooks will write it like this: subscript n combination subscript r, or some textbooks will write it as combination of n taking r at a time. Okay, choosing arrow objects from any objects without regards to order of selection. Choosing arrow objects from n objects, or choosing arrow elements from n elements without regard to the order of selection. That is this n come r. So we see that 4 come 2 gave us what? It gave us when we did 4 come 2. Of course, from, I don't know what we had then. Okay, but from the 2 combinations, it supposedly gave us 4 times 3 over 2. So it supposedly gave us 6. Yeah, from what we just did then, A, B, B, A, C, C, what we just did. Then 4 come 3 gave us 4. Now, let's find the relationship. So we see that n come r is, if you do more examples, you see that n come r is equal to n palm r divided by n factorial. I'm sorry, divided by r factorial. I'm sorry. Divided by r factorial. That's what we see when we prove it from more examples. So we'll see that n come r is equal to the combination is permutation divided by r factorial. So you have that n come r will be n factorial over n minus r factorial, all divided by r factorial. And this implies that n come r is equal to n factorial over n minus r factorial. This is what we got. So if we had 4 come 2, this is 4 factorial over 4 minus 2 is 2 factorial, then 2 factorial. And that gives us what? 4 times 3 times 2 factorial over 2 factorial times 2 times 1. This will cross out, 2 will cross out 2, and it gives us 6. Now, don't worry, I'm going to show you the thing I did. I know some of you might be wondering, what did he just do? Calm down, I will show it to you as we do this number 4, question 4. I will explain it well. Let me erase this now. So we now, that's the formula of combination that we will use. Okay, number 4, in how many ways can we select a committee of 3 from a group of 10 people? And some of you might ask, when are we going to use permutation? When are we going to use combination? How do we know whether this is a permutation problem? How do we know whether it's a combination problem? I'm going to still do another video on clearly identifying permutation and combination. But from this, I just want to say that when you don't have a specific order of arrangement, like you didn't say, in how many ways can we select 3 people, a president, a vice president, and a secretary from a group of 10 people. If you say that, then it's permutation, because you're now giving that order. It must be a president, a vice president, and a secretary. That is the way you now say specifics. You're specific. Combination is not specific. Permutation is. So 3 from group of 10 people, it doesn't matter any order. If you not, or another case is, how many ways can we, maybe you say, how many ways can we select 5 men in a committee, and out of that 5 men, 1 must be this, 1 must be the leader, 1 must be the next leader, 1 must be the secretary, just like that. I mean, you're specifying the position, then you know it's permutation. But if you just select without regards to the specific arrangement or the order of arrangement, then it's combination. But like I said, I will still do more questions like differentiating which one is permutation and combination. So look out for those videos as well. Now, but for this, it's combination because it's just selecting committee of 3 from group of 10 people. Okay, he didn't say committee of 3, president, vice president, and secretary. He didn't say that. Okay, so we just have 10 come 3. That is what we have, 10 come 3. And you can do this in your calculator, or you can use the calculator on my website. Anyone you choose to use. Some calculators, you will have it as n come r in your calculator. Sometimes you have it like this. In some calculators, you see it as n come r, just like we did. Okay, so you know how to use those. I don't know your calculator, so if I knew that, then I can kind of look at the manual and tell you how to use it. But just play around with your calculator. Okay. Now, and you just use the calculator to confirm. Don't use the calculator to just do it to give you the answer. It's not helping you. It's better you know how to do it yourself. So we see that n come r is equal to n factorial over n minus r factorial, right? So 10 come 3 means that our n is 3, our n is 10 and our r is 3. So this is 10 factorial over 10 minus 3 factorial, 3 factorial. Now look at the trick here. It's waste of time to come and start saying 10 times 9 times 7 times 9 times 8 times 7 times 6 times 5 times, keeping to list it all the way. No. Follow these steps I'm going to show you and you won't make mistakes. Now this will be equal to 10 factorial over 7 factorial, 3 factorial. See the step I'm putting in the steps. Right? So we come over here. This will now be equal to, let me write it, 10 come 3. 10 come 3. Okay. 10 come 3 will now be equal to 10 times 9 times 8 times 7 factorial, because I don't need to come and start writing 7 times 6 times 5. I don't need to do that because I see that this will come and cross out later on. That here 7 factorial will still cross out. So 7 factorial times 3 factorial. So you see, 7 factorial crosses that 7 factorial. So I now have 10 times 9 times 8. All over, now my 3 factorial is 3 times 2 times 1. You see? Then, of course, 3 into 3 will give you 1. 3 into 9 will give you 3. Now, you know, if you are wondering what kind of method I'm using, go and view my videos on multiplying fractions. You can either simplify then multiply, or you can multiply then simplify. I explained that. So view the videos on multiplying fractions for you to understand what I'm doing. But what I'm doing now is simplify then multiply. So 2 divided 2 is 1, 2 divided 8 is 4. So I now have 10 times 3 times 4. And that gives me what? 10 times 3 is 30, 30 times 4 is 120. 120 ways. That becomes your answer for number 4. Okay? Alright, now let's go ahead to number 5 and get down to this stuff. Now, number 5, it says Team A consists of 6 men and 6 women. A, how many ways can we select a committee of 5 people? Okay, how many ways can we select a committee of 5 people? Alright, now, of course, 6 men, Team A has 6 men and 6 women, and that gives 12 people. Now that didn't give 12 men, or that didn't give 12 women. That didn't also give 12 men, women. Just it gives 12 people. Okay, now, how many ways can we select a committee of 5 people? So this is like saying, how many ways can you select 5 people from 12? That is what it means. Period. That's what it means. So our A, we now have 12 come 5. That is what it means. Okay? So this will be, of course, 12 factorial over 12 minus 5 factorial, 5 factorial. Right? So this is 12 factorial over 7 factorial, 5 factorial. So this will be 12 times 11 times 10 times 9 times 8 times 7 factorial. I stop. Okay, I stop there. All over 7 factorial times 5 factorial. I cross out. Now, I'm just doing this step by step. It's not that I can't do it immediately or even mentally. I can. But I'm just doing it step by step. So this is 12 times 11 times 10 times 9 times 8. All over 5 times 4 times 3 times 2 times 1. Right? Okay, I see that my 5 and 2 will cross out to give cross out 10. Right? And my 4 and 3 will cross out 12. So what do I have now? 11 times 9 times 8. Of course, 99 times 8 will be what? 8 times 99 times 8. 8 times 9 is 72. 2 carry over 7. 8 times 9 is 72. Plus 7, 79. 792. Ways. 792 ways. Okay, that is for A. Now let's go to B. I need to erase. You can pause it and write. Yeah. Okay. Then B. How many ways can we select a committee of 4 people that has at most 1 man? Most 1 man at most. Okay. This is something I have to talk about now, and just listen, please. We have 3 terms that I have to introduce you to now. 3 terms. 3 terms. At least At most. Just. Okay. At least means greater than or equal to. At least. It means greater than or equal to. Like if I say, hey, K, may you please give me at least 5 oranges, right? That means K can give me 5 oranges, she can give me 6 oranges, she can give me 7 oranges, she can give me 8 oranges, she can give me 9 oranges. At least, the minimum is give me at least 5. You know, the minimum should be 5. Minimum of 5. She can give me 5, 6, 7 or 8, or more than that. Okay? Greater than or equal to. This means greater than or equal to. Now, at most means less than or equal to. Okay, please, may you please give me at most 5 oranges. That means K can give me 5. She can give me 4, she can give me 3, she can give me 2, she can give me 1, or she cannot even, or she might not even give me any more. Okay? So this means less than or equal to. Because, you know, at least 9 means 9 or more. At most, 9 means 9 or less. She might decide not to even give me another one. It still counts as at most. At most means maximum. Maximum should be, okay, may you please give me at most 5 oranges. Maximum should be 5. She can say, I'm not going to give you, or give me 1, 2, 3, 4, or 5. Now, just means exactly. Just or exactly. Exactly, you know, means equal. Exactly that, equal to. Okay, may you please give me 5 oranges. She brings 4, no. She brings 6, no. 5, that's what she has to bring. Okay, now, having this in mind, now let's now work on 5B. So, how many ways can we select a committee of 4 people from 12? 12 people, we select a committee of 4 people that has at most 1 man. But now, this committee has 6 men and 6 women, right? And they need 4. Has at most 1 man. So, we have to consider the cases. Cases. Number 1, the committee can have just, because at most 1 man means just 1 man or no man at all. That means it's an all-female committee. Right? An all-female committee, which, are you kidding me? All females? Now, so, the first case is the committee of 4 has only 1 man. Only 1 man. That means that, what does it mean? It means select 1 man from 6, and when you select 1 man from 6 times the other 3, because the committee of 4, only 1 man, times the other 3 is the ladies, the women. Come 3. Select 1 man from 6 and is, now that's why I said you need to view the video on counting. You really need to view the video on counting. So you know the multiplication rule and the addition rule. And multiplication rule or addition rule. So 1 man from 6 and 3 women from 6. That is the first case. Or that committee might not even have any man, because at most 1 man. It's possible, no man at all. Okay? The committee has no males. No males at all. And if it has no males, what do you have to do? You select the 4 from the 6. Period. 6 women. 4 women from the 6 women. And that is means no man there. So these are the cases you have to do. Now, if I say at most 2 males, that means you have to consider 3 cases. You have to consider the first case whereby the committee has only 2 males. That means you select 2 from 6 and 2 from 6, 2 from 6 men and 2 from 6 women. Or you select 1 from 6 men and 3 from 6 women. Or you select all 4 from 6 women. So I want you to understand that reasoning, that sense of it. Okay, so we have this. This is the AND multiplication rule, and this is the OR addition rule. So the number of ways will be 6 come 1 times 6 come 3 plus 6 come 4. Okay, 6 come 1 will give us what? Of course, if you use the calculator, I don't have my calculator, but now let me now do it mentally so you know what I'm talking about. So 6 times 5 factorial over 5 factorial times 1 will be 6. Of course. Then 6 come 3 will be 6 times 6 times 5 times 4 times 3 factorial over 3 factorial times 3 times 2. Right? So this will cross out, and 3 and 2 is 6. So this is 20. Right? Alright, then 6 come 4 will be 6 times 5, of course, times 4 factorial. I stop there because 4 factorial is bigger, even though I have 2 factorial times 4 factorial, but I still have to stop. Like now, you look at this, I know when you do 6 minus 4 is 2 factorial, don't go and extend it to 2 factorial, because you will still have to put arrow factorial. Remember, it's n minus arrow factorial. So, don't go and let you stop at 2 factorial. You know, that's what we've been doing, to stop at 2 factorial. No, we still have to put this. So, whichever one is bigger, you still put it. So, this will cross out, and 2 will cross out 3. 3 times 5 is 15. So, this gives 15. Okay, so the number of ways will now be 6 times 20 plus 15. Right? Which is 120 plus 15, which is the 135 ways. That's number 5. Okay? Alright. Now, let's go to number 6 and then we can call it a day. And you can watch more videos. Like I said earlier on, you have the calculators for this to check it. You can also go to my website and check the calculator out. Okay, number 6, a coin is flipped 10 times. A coin is flipped 10 times. How many possibilities are there in total? Okay, now when you come to a coin, toss of coins. When you toss a coin, if you toss a fair coin 1 time, okay, toss of a fair coin 1 time, you can either have head or tail. So this is the possibilities. The cardinality of the sample space is 2. But you toss it 1 time. Sample space, this is probability. Okay, please read it, you know. I think I did some, if you go to my website, you will see, go to my website, I did some notes on probability. So go to my website and do some notes on probability. Now, in case you've forgotten my website, just go to Google. You can go to Google and then type in my nickname, Samdom for Peace. Just type in this, my nickname, Samdom for Peace. It takes you, the first link is my website. Or you can just go on your URL, you type in www.appspot.com. And then when you get to my website, you click on Math, and under probability, click on notes. I did some notes there, so that will tell you about cardinality. And even the coins as well. Now, toss of coin 1 time gives you head or tail. Okay. Now, if it's 2 times, it gives you head, 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 tail, tail, head, or tail, tail. If it's 2 times, then cardinality of the sample space will be 2 raised to power 2, which is 4. Okay. If it's 3 times, the cardinality of the sample space will be 2 raised to power 3, which is 8. Head, 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 tail, head, tail, head, head, tail, tail, and the rest of tail, head, head, tail, head, tail, and the rest of them. Okay, this is under probability. So when you flip a coin 10 times, when you flip it n times, the cardinality of the sample space will be 2 raised to power n. So when you flip it 10 times, the cardinality of the sample space will be 2 raised to power 10. And what is 2 raised to power 10? You can find out. Now, you can find out one out in your calculator. My calculator doesn't have it. But you know you can find this out. In your calculator you have y raised to power x. Some people have it like this. Some folks have it like this, x raised to power y. Or some folks have it like this. So, it's also in the calculator on your computer. So if you just do 2 raised to power 10, now you have to play with it to know which one comes first. Just play with it, okay? Do 2 raised to power 2. See what it gives you 4. Do 2 raised to power 3, see what it gives you 8 before you now do 2 raised to power 10. You follow the same procedure. Okay, that is A. That is for A. Now, do that, okay? Now, for B, it says, how many possibilities contain exactly 2 heads? 2 heads. Now, of course, when you flip a coin 10 times, of course, you have, you know, assuming your, we have basically 5 heads and 5 tails. I mean, basically, you know. But now, if you flip it, what are the possibilities that it will contain exactly 2 heads? So this is just selecting 2 from 10 because it's 10 times. So this is 10 come 2, 10 come 2, which is of course 10 factorial over 10 minus 2 factorial, 2 factorial, which is 10 times 9 times 8 factorial over 8 factorial times 2 times 1. Okay, so this is 10 times 9 over 2, which is a 90 over 2. I'm now doing multiplying before simplifying. But I like simplifying before multiplying. 2, 5, so 5 times 9, which is 45 ways. That's for B. Okay, now C. Contain at most 3 tails, at most 3 tails, which means 3 or less. You see, you have to be careful now. You have to be careful here. So it could be 10 come 3 or 10 come 2. It could be 3 tails or 2 tails or, okay, I've got to clean this, or 10 come 1 or no tail, 10 come 0. It's possible to have all heads. It's possible to have all heads without tail, yes. You have head, 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 head. 10 heads without tails, yeah, it's possible. So that's it. Okay, do 10 come 3. 10 come 3 will give you 10 times 9 times 8 times 7 factorial over 7 factorial times 3 times 2 times 1. Or is the plus. 10 come 2 is 10 times 9 times 8. We've done 10 come 2 in the other one. And that gave us what? 45. Or, addition rule. 10 come 1 is 10 times 9 factorial over 9 factorial 1 factorial. Or, 10 factorial, because this is like saying 10 factorial over 10 factorial 0 factorial. Okay, what is 0 factorial? We've come to something else now. 0 factorial. Some people will say 0. It is not 0. It is not. And I'm going to tell you why. It is 1. 0 factorial is not 0. It's not 0. Now, you might ask me, because some folks have taught this, they seem confused. Why? Okay, since we do factorials, we do factorials up to the fact that it stops at 1. But what if we do 1 factorial? If we do 2 factorial, it's 2 times 1. 3 factorial, 3 times 2 times 1. But what if we do 1 factorial? Okay, we can say that this is 1 times 0 factorial. And it's still not going to give us 0. No, this is going to give us 1. So if 1 times 0 factorial will give us 1, that means that 0 factorial will be 1 divided by 1, which is 1. Okay? Just know it. It's 1. It's 1. Okay? So this will cross out, and then 3 into 3, 2, 4. So 10 times 3 is 30 times 4, 120, plus 45, plus 10, plus 1. So 120 plus 45 is what? That gives us 165, right? 165 plus 10 is what? 175. 175 plus 1 is what? 176 ways. 176 possibilities. Okay? So that is for C. At most 3 tails. Comprende? I hope you do understand it. Alright, let's do the next one. Two more to go. 6D. Contain at least 3 tails. At least 3 tails. At least. Now, but if you flip a coin 10 times, how many? You can have at least one situation whereby it will be more than, it could be 10 heads, it could be 10 tails. Now, but at least 3 tails, we have to start 3, 4, 5, 6, 7, 8, 9, 10. That's a lot to add now. A lot to add. So it could be 10, come 3, or 10, come 4, or 10, come 5, or 10, come 6, or 10, come 7, or, you know what, I have to. At least 10, come 3, or 10, come 4, or 10, come 5, or 10, come 6, or 10, come 7, or 10, come 8, or 10, come 9, or 10, come 10. Because it's still possible that we have a 10 tails. We could have tail. We can't have tails, all tails. Okay, so 10 come 3 will be what? Of course, there's something interesting here. I'm going to show it to you. 10 come 3, of course, will be 10 times 9 times 8 times 7 factorial over 7 factorial times 3 times 2. Okay, and this will be 3, this will be 2, and that will give us a 10 times 3, 30 times 2, 60, right? Now, do you know that if you do 10 come 7, it's going to still give you 60? Now, wait a minute, let me see. 10 times 9 times 8 times 7, okay, 7 times 3 times 2, so 10 times 3, oh, 2 into 8 is 4, I'm sorry. This is 2 into 8 is 4, so this is 10 times 120. Yeah, because I was wondering, we got 120 the other time. I couldn't get 60 yet. Okay, so 120, right? Now, do you agree with me that 10 come 3 is the same thing as 10 come 7? We can see. If we do 10 come 7, it's going to give us 10 times 9 times 8 times 7 factorial over, in this case, even if 10 minus 7 is 3 factorial, but 7 factorial is still here, so it will still be 10 times 9 times 8 over 3 times 2 times 1. So 3, 3, 2, 4, which is 120. 10 come 3 is equal to 10 come 7. Now, there are something important. N come R is the same thing as N come N minus R. Yes. Yeah, it works. So if we find 10 come 4, it's the same as 10 come 6. Simple. Okay, so this is a plus. 10 come 4 will be 10 times 9 times 8 times 7 times 6 factorial all over 6 factorial times 4 times 2, 3 times 2 times 1. Okay, this crosses out. Now, 4 and 2 is 8. Then 3 here, 3. So 10 times 3 is 30 times 7, 210. Look, I got it right. And if this is 210, okay, let me make sure I got it right. 4 times 3, 4 times 2 is 8, then 10 times 2, 30 times 7, 210. Okay, and if this is 210, that means that 10 comes 6 will also be 210. So plus. Let me circle it because I'm fixing. I will add this soon. Right? Then 10 come 5 will be the same thing as 10 come. Okay. 10 come 2 and 10 come 8. 10 come 1 and okay. So now 10 come 5 will be what? Plus 10 times 9 times 8 times 7 times 6 times 5 factorial all over 5 factorial times 5 times 4 times 3 times 2 times 1. This will cross out. Now 5 and 2 will cross out to 10. Then 3 will cross out 1. 6 is 2. 2, 1. 2 into 4, 2. 2, 1. 2, 8 is 4. So what do I have? 9 times 4 is 36. 36 times 7, right? 36 times 7, 7 times 6 is 42, carry 4, 7 times 3 is 21, plus 4, 25. Sometimes 6 is 42, carry 4, sometimes 21 plus 4, 25. Okay, plus. Then 10 come 8 will be, this is still plus, all addition. Okay, will be 10 times 9 times 8 factorial all over 8 factorial times 2 times 1. Okay, which is 45. 45 plus 45. Right, plus 10 come 9, of course, is 10 times 9 factorial over 9 factorial times 1 factorial, which is 10. 10 come 9 is 10. And 10 come 10 should be 1. 10 factorial over 0 factorial, 10 factorial, right? That is 1. Okay, so let's add all this stuff. Let's add it up. Okay, so of course 120 plus 120 will give me 240 plus 210, and let me just cross that as I add them. 120 plus 120 gives me 240. 210 plus 210 gives me 420, right? 252 plus 252, right? Then 45 plus 10 is 55. 55 plus 1 is 56. 56. So this is 8. 4 plus 2 is what? 6. Plus 5. 11 plus 5. 16. 1 plus 2 is 3 plus 4. 7 plus 2. 9. 968 ways. Yup. Now let's do it again. Plus 5, 11 plus 5, 16. 1 plus 2, 3 plus 4, 7 plus 2. Yeah, that's just 8 ways. Okay. All right. One more and we are done. One more and we are done. Palm and comb. Palm and comb. So I believe you can, after looking at this video, you'll be able to solve the questions on your homework. All right. Contain the same number of heads and tails. Now contain the same number of heads and tails. So that means 5 heads or 5 tails. I mean 5 heads. You know, it has the same number of heads and tails. So you can either say, because it's 5 heads, 5 tails. Exactly 5 heads, or you can say exactly 5 tails. Right? So yeah, that's head, 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 then head, head, sorry, head, 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 then tail, 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 tail. So it's 10.5 because it's gonna be, you know, this last question means exactly 5 heads, or you can also say exactly 5 tails, whichever one, you know. But if it contains 5 heads, then of course it will contain 5 tails anyway, because you only have 10 times. So the same number is head, 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 tail, 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 tail. 5 heads or 5 tails, whichever one you choose will work fine for it. So it's 10.5, which is 10 times, 9 times, 8 times, 7 times, 6 times 5 factorial, all over 5 factorial times 5 times 4, that's 2 times 1. This okay, 5 and 2, 10 goes, 3 goes 1, 3 goes 2, 2, 1, 2, 2, 2, 1, 2, 4. 9 times 4 is what? 36. 36 times 7 is what? I think we got 250. Okay. I will have the calculator on my website so that you can check your work as well. Thank you so much for listening, students, and you have a good evening.